So let's take a few moments now to talk about where earthquakes actually occur. And as you might guess, all of this is going to be a throwback to plate tectonics, right? So most of this little section here should actually be a good review. So when we talk about our earthquakes, obviously they are occurring vertically, right, inside the earth. So we can have shallow earthquakes, which we tend to find at divergent and transform boundaries, or we can have intermediate and deep earthquakes. And those we tend to find at convergent boundaries, especially above subduction zones. So let's take a look at that. So at our divergent plate boundaries, right, what we're experiencing here is just the earth, right, remember, breaking apart. Right? So essentially, remember, one plate goes in one direction, the other plate goes in the other direction. So because of that, we're not getting a lot of interaction down deep. It's mainly up here. Because remember, right, the deeper you go inside the earth, the warmer it becomes, which means those rocks can bend easier. Rocks typically only break, right, when they're cold up at the surface. So what we're experiencing here is just very shallow earthquake activity. Remember, we're going to get two types of faults, normal faults and strike-slip faults. So our normal faults we're going to find here in the Rift Valley, and our strike-slip faults, right, we find all along the transform boundary. But our shallow focus earthquakes occur, anywhere from right at the surface to 10 kilometers deep. Interestingly enough, the shallower the earthquake tends to be the more destructive. Now, we don't find destructive earthquakes generally at our divergent boundaries, but just keep that in mind. That shallow tends to be a little bit more dangerous because that energy doesn't have much of a chance to dissipate. Now, our convergent plate boundaries, these are a little bit more complicated because not only are we getting interactions here at the surface, but we're getting interactions right all the way down here. Right? So this is why we can have shallow, intermediate, or deep earthquakes appear at all three, because we have all of this area in which our two plates are interacting with each other. Now, what makes it even more difficult is I want you to remember that the Earth's plates aren't constantly in motion. They're not moving every little millisecond of the day. They're only moving when they have to move, when there's been enough stress built up on them. So what happens a lot is we get these two plates, right, that are pushing against each other. And what will eventually happen, right, if here I have my subduction zone, this plate that's on top will bend, right, with this pressure. So just imagine, right, you've got these two plates pushing against each other, right, and then what will eventually happen is this will flatten out, so it'll pop up, and this will slip downwards. And that's where we get these really, really big earthquakes from. So most of these earthquakes that we've gotten in Japan and Haiti and all of those really massive earthquakes have been from something like this over a convergent boundary. That's this snapback that your author is talking about. So I want you to realize, like I said again, that we get earthquakes all along this entire plate. So as you can see here, right, some of those really big earthquakes, those ones that are 8s and above, are always at your subduction boundaries. Now, we also have to realize, again, like I said, the deeper the earthquake, even though it might generate a lot of power down there, it dissipates by the time it comes up to the surface. So generally, the deeper the earthquake, the better it is for the people living on the surface, because we don't feel all of that stuff. The shallower the earthquake, the more dangerous it is. However, I do want you to realize that we don't really get earthquakes below 660 kilometers, because down there we have a boundary. All right, so basically what we see is below 660, the Earth is very ductile, right? It can bend. It's bending more than it breaks, right? You can't really break a liquid very well, right? So down here below 660, the Earth is too partially molten for it to break. Now let's take a look at our transform boundary. So here we have a transform boundary. Maybe you don't see it, but it's right there. Transform boundaries, again, is where our plates are sliding past each other. And since they're sliding past each other, generally what we see is these tend to be pretty shallow focus earthquakes as well, just like those divergent boundaries. Most of our transform boundaries are associated with divergent boundaries, right, at our mid-oceanic ridges. However, there's a couple of instances where we actually have transform boundaries on the crust. They are very rare. The one in our country is the San Andreas Fault. Okay. Now, these large transform earthquakes that are on the continents can actually make an immense amount of damage. Fortunately, they don't make a lot of damage below the ground, but above the ground they definitely do. So one very famous large earthquake was one that occurred in the San Andreas, and that was in 1906. And what happened is again, these plates build up tension, right, all along the boundary. And they only move, like I said, when they're forced to move, right, when that energy has built up so much that these plates physically have to move to get rid of that stress. And there was a really large earthquake in 1906 on the San Andreas. It was a 7.9, which is pretty major, right? Even if a 7.9 were to hit California today along the San Andreas, right, that would be pretty major. However, the biggest problem here was that most of San Francisco was built, right, with wooden structures. And when you start breaking gas lines and things like that, and you got wooden structures around them, we start to get lots of fires and all sorts of things. So pretty much almost all of the town of San Francisco was destroyed by this earthquake in 1906. And we have to realize that this whole boundary is incredibly active. There's a lot of movement here. So we know that in the future we're going to get large earthquakes again along sections of the San Andreas that are very heavily populated. Now, what about our continental rifts, right, our divergent boundaries that are on the land? Well, we do get some earthquakes there as well, but they're shallow focus earthquakes. So here you can see, right, we've got the earth breaking apart. So what we're going to get here are just these nice little normal faults that are going to happen as the ground just kind of slides down. And that's where the earthquake happens, is just right along that little fault line as that earth kind of slips down as everything starts to open up. Now we have two rift valleys that are starting to open up in our country, the Basin and Range Province and the Rio Grande Rift, which eventually all of this area will hook up into one big rift valley. So yes, North America is starting to break apart into two pieces, but we don't have to worry about that for quite a while. The East African Rift Valley is has progressed a lot further than where we are in North America. But again, these are shallow focus earthquakes. They're not very major at all. Now what about our collision zones, right, where continents collide with each other? Again, we are going to get earthquakes, but it's pretty much limited to right up at the surface. So we don't really get too many deep earthquakes with our collision boundaries. However, these earthquakes can be really large. And the biggest threat from them is that they can make landslides. Right? So as these two plates continue to grind into each other, what can happen is you get enough shaking, you're getting enough landslides down this nicely new made vertical structure, right? So these can be pretty dangerous as well. Now what about earthquakes that happen in the middle of the plates? Right? Well, as we've seen, most of our earthquakes occur along plate boundaries. However, on occasion, we can get what are called intraplate earthquakes. So they do happen inside of the plate. Now, most of the time, these intraplate earthquakes occur because there's a remnant boundary there. And we see this in our country. So right here, this is the New Madrid fault line. In the New Madrid fault line, what we see is North America way back in the Precambrian actually tried to split into two pieces, where the southern section was breaking away from the northern section. However, this is a failed rift. It started to open up, and then it stopped. So we still have a weak plate, or weak spot here, right, in the middle of our continent. So on occasion, what happens is we still get earthquakes along this weak spot. And it's not that the earth is continuing to rift there. It's just like when you break a plate and you glue it back together, right? Well, it's still weak, right? So we get the same thing here. And we've gotten some really large earthquakes in this zone. In 1811 and 1812, there was several 7.0 earthquakes. And what happened here is, if we were to look at this in cross-section, so here's the south end, here's the north end. The north end actually dropped downwards. So when the north end dropped downwards, the Mississippi River actually flowed backwards, right? It actually flowed from the south to the north for a period of time before it eventually reversed itself. So these old rift zones can actually have a pretty major impact, right? All the way, say, down here in Louisiana. It's pretty impressive stuff.